Hello my friends, this is my first look at geometry nodes. So I'm sure you've heard by now that there is this idea called everything nodes. And we've seen something before that was the particle nodes, and now they've sort of disappeared again. And I think it's kind of sad because I would like to see the particle nodes come to life and be production ready. But instead of the particle nodes, now we have geometry nodes, and they're actually part of 2.92. And I'm using 2.93 alpha now, and the geometry nodes are, of course, also part of that. So you don't need any add-on. It's just part of Blender, and it will be part of Blender 2.92 and onwards. So let's jump right into Blender and see what it's all about. Alright, here I am in Blender 2.93 alpha, like I said. This is my startup file. You can get that from Patreon. I have a separate video here on the channel if you're interested in my startup file. And I think I'm just gonna clean up this. I don't need the asset browser. And really, I don't want the rendered view either. We're just gonna take this, and down here, we're going to open the geometry node editor. And this is the new thing in Blender 2.92 and later. All right. So I'm gonna select this outer sphere here in the scene. This is the preview orb, this outer part. And I'm just gonna click new here, which creates a new geometry nodes node tree. So very similar to animation nodes. Oh, by the way, if you're new to my channel, I have a whole lot of videos here on this channel about animation nodes, which is an add-on for Blender. It's a free add-on, and it's very, very good and amazing. But it's an add-on. So geometry nodes is part of Blender, and it's more integrated into Blender. And I think it will be the next big thing in Blender. And we're gonna find out today what it's actually capable of now. Of course, this is still under very heavy development, so this is not final. This is not, you know, the thing that you will have in 1 or 2 years from now. But it's a start, and we're gonna look at it from the start, and we're just gonna grow with it while this becomes more and more advanced. So make sure you're subscribed to the channel, and I will make new videos when new features come out. All right, so we have a node tree, and it's the same thing as with the materials or the shaders or the animation nodes. It's a node tree. We have inputs and outputs and noodles in between. And really what this does is it modifies geometry. So it modifies the mesh of your object. So for example, here we have the group input, and here we have the group output because I clicked that new button. That, in fact, you know what, I'm gonna take that subdivision off here. That created a geometry nodes modifier, because geometry nodes are modifiers. So they're part of the modifier stack, and you can place them in the correct order or position on the modifier stack. And each geometry nodes modifier uses a geometry nodes node tree. And that's what you see here. So this is the geometry nodes modifier, and it's using this geometry nodes node tree. So if I call this geometry nodes 1, now I'm using this on this object in that modifier. I could add another one, or I can reuse that same node tree on a different object in its own modifier. So that's already pretty cool that we can do that. Now, this is quite boring right now because we have group input and group output. And what that says is take the mesh info and I'll put it onto the object's mesh data. So it's not doing anything. But for example, we could add a very simple node, which is the geometry transform node. So by the way, I'm hitting Shift A, and you know what? I'm gonna hit turn on the screencast key so you can see what I'm typing down here, and maybe also enable this little blue circle so you can see where my mouse is. Maybe that helps when you watch this on YouTube. Okay, so we have a simple node in between here now. we're actually doing something with our mesh data. We're transforming it. So I can shift everything to the X or to the Z. Now you might be thinking, this is not really very wonderful, but we're actually shifting the mesh data. So just like all the other modifiers that modify or generate mesh, we're moving the mesh information, and you can see that down here. Our origin point is still down here. So if I go in here and I move the object, I'm moving the origin point, right? But if I'm moving the mesh, just like if I went into edit mode and then moved the mesh around, that's what geometry nodes do. So we're moving the mesh, we're transforming it, we can shift it, we can rotate it, and we can scale it. And one thing you might already have seen now, if I select this object and go into edit mode, my mesh is still over here. Because think of it as like with all the other modifiers. If you have like a displace modifier, for example, your mesh is still in the original spot. The modifier then shifts it, and that's where it appears. But the mesh data is still right here. So the transform just shifts the mesh info around like all the other modifiers. And since geometry nodes is a modifier here, that's what happens. So you can also see we have geometry in, geometry out. So the geometry nodes, like almost all of the nodes in here, have this sort of in and out. It's always geometry in, geometry out. And the node does something to the mesh data. So let's see what else we have. We have, first of all, here we have the whole attribute thing. I think this is going to be a separate video. I don't think we will get to that in this one. Then we have color ramp, combine RGB, separate RGB. That's stuff we already know, and it's basically the same nodes. They're just available for us in here also. So you might know those from, well, from animation nodes and from, of course, from the shader nodes. So then we have geometry, and we're already using the transform. There's also join geometry. So we can take mesh info from two different objects and join them together in one mesh data block, basically. So what does that, what can we do with that? We only have one input, and that input is the mesh info of the node that the modifier is on that uses this node tree, right? So where do we get more geometry from? Well, we could go to input object info, and we can take another object in here and get more geometry. So we can take our geometry. So let me connect this up here, and then take the geometry of a different object. So let's say this one. So I'm gonna just eyedropper that in here. So now we have the geometry of the preview base object, this one, and our original object. And we're gonna plug that into our output. So what happens? Well, maybe we should put it in here so we can shift it over a little. So now look at that. We took the geometry of our object that the modifier is on. We also took the geometry of that base object down here. We joined those together, and now that gives us new mesh data, and that's the output for this preview orb object. So this object now contains the mesh with the base basically copied into it. Okay, so that's that. Cool, so we can join a geometry together, and this object info node also gives us location, rotation, and scale, which would be these settings here. Cool. Now, what else do we have? Input, right, that was it for geometry. Then we have input object info, we are already using that. Then we can get a random float. Well, that's kind of clear what that does, right? It gives us a value, just a single value. We also have that in the shader nodes and in animation nodes, and a vector. Very simple. But wait a second, there is vector combine XYZ also. So this makes no sense to me. This node is basically useless. Because this node does exactly the same thing, and it has input sockets. So this is definitely the more valuable node. This one I can live without, I would say. What else do we have? Vector. Okay, then we have mesh. Boolean. Okay, cool. So now this is getting very interesting. We can, so here we're joined to mesh infos, geometry, right? We could also use Boolean, which is just like the Boolean modifier that you can add to any object here. And it takes the method or the operation. You can intersect union or difference. And of course you need two different types of geometry. So let's see if we can come up with something cool here. So I'm just gonna get rid of this. The transform might be interesting. Let's add a cube, but not in edit mode. Delete those vertices. Let's add a cube. Okay. And this is already cool. So can we go in here? Where is my object? It disappeared because it has no geometry at the moment. Let's give it its original geometry. So this is what we have. And then we have the cube. Now let's get the cube in here. So we take an input object. We eyedrop the cube, plug that in there. Take our original data, and then we do, well, let's do intersect. Plug that in here, plug that in here, just so we can see what's happening. And this is what we get. So now we have a Boolean operation as a node in a node tree inside of a modifier, instead of just using the Boolean modifier. Okay, so what does that do? Yeah, okay. So the order here is also very important. Just like with the order in the modifier stack, now you have an order of the flow through your node tree. So first we're doing the Boolean operation, and then I'm transforming. Okay. So what if I transform my original geometry first, use that for the Boolean operation, and then what do we get? We get, what is this? Cool. Okay, so we're actually getting the intersection of our original sphere here with this cube, wherever the cube is. And I'm transforming the mesh before I'm cutting away. Yeah, so this makes sense. So basically the cube now, original or relative? Ah, okay, original, relative. So what if I move this? Okay, so we have this option here to set, what does it say here? Output the geometry relative to the input object transform and the location, rotation, and scale relative to the world origin. Okay. So this, we have to switch around so we can use that. But I think, to me, at least, it makes more sense to have the Boolean first, then we get the intersection or that object slice basically here, and then we can move that around. So what if I move that? It cuts away from here. Cool. So let's reset that location. Awesome, so we have a Boolean node in here. What else do we have? Mesh edge split. Well, there's the edge split modifier that you might be familiar with. So we also have a node for edge split. This is interesting. And what that does is, just like the modifier, at a certain angle, so at sharp angles, it cuts the mesh apart and makes actually separate objects, separate geometry out of it, right? So if you have a sharp angle, and this is all one mesh, with the edge split, it splits along the edge and creates a plane here and a separate plane here, for example. And that gives us very sharp corners here. So that's what we get from that. Very nice. Maybe I should switch this to matcap so we can see a little better what's happening. All right, and maybe also wireframe. Maybe that helps. Cool. So that's what the edge split does. Mesh subdivision surface, well, we all know what that does, right? It subdivides, we can set the level, use the creases or smooth UVs. It doesn't, the nodes in here, at least not now or for now, don't give you all the extra details and options and possibilities that the modifiers give you, but they're here. So you can modify your mesh and then add a subdivision surface modifier and stuff like that, all in a node tree. You don't need the modifiers basically. Okay, so subdivision, and then we have triangulate. Well, this is also very simple and obvious what that does. So we can mute that, and we have the quads, the original ones from our orb, or with the triangulate, we get triangles. All right, that's pretty cool. Let's plug that back in here. Cool, so this is intersect. What if we do union? Then we have our object that the modifier is on now has this geometry. Interesting. So we combined with Boolean unioned geometry together. And then of course we have a difference which cuts the cube away from our geometry. So if I make this cube smaller and move it up, and then we're cutting out this kind of thing. Bring it forward. Right. So this is all done with nodes. Okay, let's get rid of this. What else do we have? We have points. Now this is the stuff that you might have already seen. There's a lot of videos out already using point distribute and all of that stuff. We're gonna look at it right now in a few seconds. Maybe, what do we have? Points to volume. Okay, this is new, I think. I don't know what this does. And then we have utility classes. Boolean math, cool, and or XOR not. Clamp node, we already know what that does. We have a float compare, so we can have like an if statement. If A is less than or greater than, and it gives us a Boolean. What else do we have? We have a map range. We already know what that does because that is also part of the shader nodes and also in animation nodes. And then we have our good old math node with all of the math operations, of course. Very nice. So this is all stuff we can use inside of the node tree to do stuff to the geometry. Then we have vector, combine, already saw that, separate, okay. Vector math, I'm sure that's the same, yep. Dot product, for example. So here we have some utility classes, and of course we can group stuff together, just like in shader nodes. So you can take like a whole setup, put it in a group, and then that group has input sockets and output sockets. Very, very handy stuff. And of course we can lay out our node tree with frames and reroute nodes. Awesome. Now let's look at points. Okay. So this is what we have now. So what do we have in the points? Align rotation to vector. We're going to look at that later. First of all, we have point distribute. Okay, so how about we do this and we take our original geometry, do point distribute, and plug that into the output. And look at that. What is this? Okay, so point distribute gives us, or all the point nodes in this point menu here are for point clouds. So this gives us basically just the positions in 3D space, like a point cloud. But remember, each point has not only a position in 3D space, but also has a location, a rotation, and a scale, which you might not make sense when you think about it. It's just an infinitely small point, but using these attributes, location, rotation, and scale, you can do some awesome stuff with it. So first of all, what does point distribute do? Well, it distributes points on the surface of the mesh. Now the mesh is gone. My original preview orb is gone because I'm using it and I'm basically changing its mesh info, its geometry, and that is its new mesh info or geometry after. So original is gone. How do we get the points and the original back? Well, I would think that we could do join the new one with its original one and do something like this. Yup, now we have the original object back and we have those points. I think I'm gonna get rid of this cube. Okay, so we have points. Here we have density, which is just how many points do you want to distribute on the surface of the mesh. We have random or Poisson disk. I think that's how you pronounce it. I'm sure it's not poison. So what does that do? It is basically an algorithm to avoid collisions. You can say, you can basically define like a size of around this point, and you don't want other points to be inside of that range. So you can crank up the density here and you get distributed points on the surface and they're not colliding. Cool. So we also can use a density attribute. Now let's see what we can do here. For example, I could go to weight paint mode. So this is my object. Hold on a second. I'm going to disable my modifier here so I can see what I'm doing. And I'm just going to paint some weight on the side here. Paint on some weight. The wireframes are kind of in the way. Okay, so do something here and then maybe do something up here. Okay, now weight painting, if I go to object mode, creates a vertex group called group. I'm just gonna call it W for weight. And this weight now is an attribute you can use inside of geometry nodes. So I can re-enable this modifier first. So we have them all over the place. And if I now use this weight attribute for the density, then we have only points distributed where the density is high, or more points where it's 1, and then you know, this is like a grayscale value. So this is very similar to particle systems where you can also use weight paint and tell the particle system use that vertex color or the weight for, like, for example, the size of the particle or the length of the hair. So this is what we can do in here with the point distribute. Cool. Okay, what else do we have? Point instance. Cool. So now what is this? This is not geometry. If I switch over to some rendered view, you can see this is nothing. This is just, these are points in 3D space. They have no visual representation. You can only see them here because Blender is nice enough for us to show where the points are. So what can we do? We could instance another object to those points, right? So let's put in a monkey. So here we have Suzanne. Let's go back to this one. We pick Suzanne and we tell this geometry, which is just the points. So this is the geometry of the orb that we're joining back together with this one. But these are just the points, okay? And at each point we want a Suzanne. Let's plug that in here. So now we have a bunch of Suzannes, huge Suzannes actually. So we could go into Suzanne edit mode and scale down Suzanne like this, right? Or how about we scale the points? Remember I just said each point has a position and location, rotation, scale. So of course there is a point scale node in here. And we can scale using an attribute or a vector. And we can change this vector in here to scale Suzanne. This is cool. Okay, so now we have a bunch of Suzannes here. We can also see that they're aligned according to the normal of my original geometry, which is very nice. Indeed, it's like the hair particle systems. But with that note that sort of doesn't fit into that naming scheme yet, align rotation to vector, we can put that in here first. Right, don't get confused with this stuff. How about I just plug that in here and this in here, so we have our original object back. So with this one, they're still aligned. Are they still aligned? What about if we set this to C and then we can change X, Y, Z? So you can see you can define a vector and you can align the rotation of the point to that vector based on its original rotation, which is the normals, right? So you can play with that. And also very interesting, the nodes in here, they always or very often have this possibility to switch between an attribute, and then you can use an attribute as a factor here. So you could use the position attribute to influence the rotation, for example. Or you can use a float, and then you get a float factor that you can even animate. And then the vector you can also change. You could use an attribute. So instead of the vector that you define in the node here, you could use a different attribute. Like I said, the attribute workflow of geometry nodes, I think, will be a separate video. But yeah, well, that's stuff you can do, and you will find this very often. Like also here, you can have a vector or attribute. So if you set it to attribute, you have to enter the name of an attribute. Cool, so we're scaling our Suzannes. Interesting, interesting. Point instance, right, so that gives us the Suzannes. What else do we have? We have point rotate. Well, can plug that in here. We can rotate all of our points. Remember, we're not rotating the Suzanne, we're rotating the point, and then we're instancing the Suzanne onto that point, and of course that inherits the location rotation scale. So point rotate also has several options here. The ratio again can be an attribute or a vector, so you can use a different attribute to influence this node instead of basically hard coding it in here with these. And what else do we have? Scale, already did that. We have point separate. We have point translate. Well, that's a simple one, right? So we can take all of these points, set this to a vector, and move them over on the x-axis. Again, we're transforming the points, not the Suzannes. Only back here, we're putting a Suzanne onto every point. So we can translate, okay. And then we have point separate. So this is interesting. It takes a geometry and outputs two geometries. And it separates the geometry using a mask. Okay, let's see. We go to our object. We create a new vertex group. Call it mask. I'm just going to call it mask. Go again into weight pen mode. And then draw down here maybe. Okay. So like halfway like this. Cool. Object mode. Now I'm gonna take all of my points that I have. I'm gonna separate them using the mask, which is an attribute, and I called it mask. And that should give me these points and those points. Wonderful. So how about we instance a monkey onto this set? Like so. Let me organize this a little bit. So now we only have a monkey on the upper part here, the first set of points. And right here we can, for example, take, I don't know, create a cube. Maybe scale it down in edit mode real quick. And a duplicate point instance. Take this set of points, but with the cube. Was that the cube? No, cube. And then copy the join. So let's create this geometry and this geometry and join that onto our original geometry. Look at that. So we used a mask, a weight painted mask, to separate a set of points into two sets, and then we can do stuff with those points. Cool stuff. Okay. Now, of course, we can go in here again, maybe take a point translate node, plug that in here, move. No, that's the wrong position. Sorry, I want to do this here. So I want to move maybe the monkeys over to the left a little. And also in here, move the cubes over to further out to the right. And also maybe, now I'm gonna need some more space. Also take point scale and make the cubes a little bigger. So you can see we're playing with mesh info. We're actually playing with the geometry here. That's why it's called geometry nodes, I would say. Okay, now let's just quickly recap. First of all, we have an object. That object has a modifier on it, the geometry nodes modifier. Very new, very cool. And that modifier uses a specific node tree, which is the one you enter in here. So if I take this object, for example, and remove the subdivision and add a geometry nodes modifier, but not with its own geometry node tree, but using the same one, you can see now we have Suzanne's all over this object as well. Of course, it doesn't have a weight attribute because this object now doesn't have that weight painted vertex group. So it's just everywhere. And of course, it doesn't have a mask either. So it's just everywhere. But you can see that it's just a modifier, and you can reuse the node tree in the modifier. And you can have multiple of those modifiers on a single object, and they have a like an order, like all the other modifiers. Cool, so that's that. Right, then we have node trees, and we have special nodes in here for that type of node tree. And of course we have like utility nodes, just like in the shader nodes or in animation nodes, for vector and math operations and all that. And then of course we have specialized nodes for geometry nodes, like the mesh nodes in here, like the point nodes in here, and like the attribute nodes. And we're gonna look at that in the next tutorial. So if you like this video, please give it a thumbs up. Make sure you're subscribed if you want to know more about geometry nodes. And of course, like I said, they're heavily working on this at the moment. And like every week, a new node comes in and new features. So I will stay on top of this. I will make new tutorials when new information is available and new nodes and new cool features are available. Now, if you're a fan of animation nodes like me, you might be wondering, well, does this replace animation nodes? Well, not yet. But like I said at the beginning, this is integrated into Blender. The guy who invented animation nodes is actually working on this at the Blender Foundation. So sooner or later, I'm pretty sure that we will be using more geometry nodes for visual effects, for motion graphics, which was stuff that could only be done with something like a Sverchok or animation nodes. So, well, I think this has a lot of potential, and I hope they also bring back the particle nodes, because setting up particle systems using a node trees and the fact that you can do stuff like, if the particle hits this plane, then create 10 new particles at that spot, shooting out, and all sorts of stuff that are possible with the particle nodes. I hope that all of this comes together into this big idea of everything nodes. Let me know in the comments below what you think. Do you think this is a cool way of creating and manipulating geometry? I think it is. And I think using node trees for this is also very cool. Although very often node trees can become very, very big and hard to understand, because it's just visually very complicated for things that are actually very simple. I hope you enjoyed this video. I hope you also like the next one, where we're gonna look at the whole attribute workflow in geometry nodes. This is also a very, very cool feature, where the whole motion graphics side of other software, other 3D software, comes into Blender now with geometry nodes. So make sure you're subscribed. Please like the video if you liked it. Thanks for watching. Crispy out.